Now let's look into the manual calculation of standard deviation using the IQ, student IQ example. So for class A, if you remember, we have calculated the variance. So the variance for the class A was 235.45. Let me show you somewhere here. We have done it. Yeah, here it is. Sum of the squares and sample size and variance is 235.45. Okay, now to calculate the standard deviation for the same class, yeah, simply you have to do the square root of that. Let me do that. Yeah, here it is. So let me check std class is equal to, again, mat dot square root of variance. Std class, it's 15.3. So let me execute this. It's 15.34. 15.34. That's what the standard deviation for the class A. What does it mean? So when the variation was 235.44, we asked, what does it mean? How does it make sense to me? The same question I'm asking you again. What does it mean? How does that make sense to us? This conveys that the average of persons deviation from the mean IQ of 110.54 is 15.34 IQ points. That's what the information it conveys. The average of persons deviation from the mean IQ of 110.54. The mean IQ is 110.54 is 15.34 IQ points. That's what it tells. Okay, just review one more time whatever we have seen so far from where we have reached here. So we have begun with deviation, calculating the deviation, that is yi minus y bar. So this is basically, individual observation minus average or mean of the population or sample. Once you get the deviation, to suppress the negative values, we have squared the deviation. Once you have squared the deviation, now it's time to sum up all the squares. S as sum of squares. Once you have sum of the squares, then you have to calculate the variance using the formula sum of squares divided by n minus 1 if it is sample, or capital N if it is population. Then finally, here is your standard deviation. So standard deviation is nothing but square root of variance. That's it. So now let's understand a standard deviation in detail. So let's take this example. Let's consider larger SD. So larger SD, larger standard deviation, equal to greater amounts of variation around the mean. For example, let's take two examples. This this is the first distribution, and this is the second one. Two data points. Let's take first one is class A students and second one is class B students and their respective computer science marks. So the mean for both is 25 25. Y bar is 25 for first curve, that's a class A distribution, and for the class B distribution is also 25. So 25 25. Okay, now but the by looking at the by looking at the shape of the curve, you can tell that the by looking at the range of the curve, you can tell that the first curve will have a lesser standard deviation and second one will have a higher standard deviation. The same happened. So standard deviation of the first curve, that's a class A's distribution is 3 and second one is 6. So as SD. So now SD, when SD is equals to 0, only when SD is equals to 0, only when all values are the same. So if you were to rescale a variable, the SD would change by the same magnitude if it changed units above. So the mean equal to 250, the SD, the standard deviation on the left would be 30, on the right 60. Like the mean, the will SD will also be inflated by an outlier case. SD, like the mean, the SD will also be inflated by an outlier case. And I just want to repeat a point one more time, that a smaller standard deviation that you see on the screen left side, a smaller standard deviation which is a 3, indicates that the data points are closely packed around the mean. That's what you can see with the on the image also. The standard deviation, which is a larger standard deviation, indicates that the data points are spread out. The data points are spread out.